252 million years ago, the Earth stood at the edge of a transformation no living creature could have imagined. There was no brilliant flash in the sky, no mountain-sized asteroid racing toward the planet, no single moment that announced the end of an age. If you had been standing on the shore of an ancient sea, everything would have seemed almost ordinary. Waves rolled gently across the coastline. Forests swayed beneath the wind. Animals searched for food, defended their territories, and cared for their young. Life had every reason to believe that tomorrow would be much like today. For tens of millions of years, the planet had remained remarkably successful. Life occupied nearly every environment. Dispersed forests covered enormous regions of land. Rivers crossed vast floodplains before emptying into warm, shallow seas. The oceans supported thriving ecosystems filled with creatures unlike anything alive today. This was the final chapter of the Permian period. At the time, almost all of Earth's continents were joined together into a single enormous landmass known as Pangaea, stretching across thousands of kilometers. It was the largest continent our planet has ever known. Around it lay a single immense global ocean called Pangaea. The geography of Earth looked completely different from the modern world. There was no Atlantic Ocean, no separate North or South America, no Europe divided from Africa. Instead, nearly all land formed one colossal supercontinent, surrounded by water. Along the coastlines, conditions were relatively mild, but far inland, the climate became much harsher. Many regions experienced long, dry seasons, intense heat, and very little rainfall. Other areas flooded with seasonal rivers before drying once again beneath the sun. Despite these extremes, life flourished. The land belonged to animals that lived long before the first dinosaur ever appeared. Large herbivores wandered across open landscapes, feeding on hardy vegetation that had adapted to the changing climate. Powerful predators followed them through forests and across river valleys. Among the most successful were the therapsids, distant relatives of the mammals that would not appear until much later. Some resembled enormous reptiles. Others already possessed features that hinted at the future evolution of mammals. One of the most common animals was Lystrosaurus, short, heavy-bodied, and equipped with two distinctive tusks. It spent much of its life feeding on low-growing plants. It was not especially fast. It was not especially dangerous. Yet it would eventually become one of the few large land animals capable of surviving what was about to happen. Elsewhere, fierce predators known as gorgonopsians hunted across the continent. With long saber-like canine teeth and powerful jaws, they occupied the top of the food chain. Huge armored herbivores called parasaurs slowly crossed the landscape. Countless smaller reptiles, amphibians, insects, and early vertebrates filled every available habitat. Together they formed ecosystems that had taken millions upon millions of years to develop. The oceans were even richer. Coral-like reefs supported extraordinary communities of marine life. Brachiopods covered vast stretches of the seafloor. Crinoids extended delicate arms into the currents to capture tiny particles drifting through the water. Ammonoids swam through the open sea, inside beautifully coiled shells. Ancient fish occupied nearly every level of the ocean. And on the seafloor lived one of the oldest and most successful groups of animals in Earth's history, the trilobites. For more than 250 million years, trilobites had survived changing climates, shifting continents, and previous extinction events. Gelidation after generation, they had endured, while countless other species disappeared. Few could have imagined that their story was approaching its final chapter. From every direction, the world appeared stable. Forests continued to grow. Animals continued to reproduce. Predators continued to hunt. The seasons arrived exactly as they always had. Nothing suggested that life on Earth was approaching the greatest biological catastrophe ever recorded. Yet deep beneath what is now northern Siberia, the planet itself was beginning to change. Far below the surface, enormous volumes of molten rock slowly accumulated inside the crust. Pressure continued to build. The first fractures quietly spread through ancient rocks. No animal could hear them. No forest could sense them. But the forces gathering beneath the ground would eventually transform the atmosphere, poison the oceans, destroy ecosystems across the globe, and erase much of the life that had taken hundreds of millions of years to evolve. The world was still peaceful, but its time was running out. The immense size of Pangaea shaped nearly every aspect of life on Earth. Unlike today's continents, where oceans lie relatively close to most regions, much of Pangaea's interior was astonishingly far from the sea. Moist ocean air rarely reached the center of the continent. As a result, vast areas remained dry for much of the year. Some regions experienced scorching summers, followed by surprisingly cold winters. Others endured long periods without significant rainfall before seasonal storms briefly transformed the landscape. The climate was often unpredictable. Only plants and animals capable of adapting to these changing conditions could survive. Forests covered many parts of the continent, but they were not endless tropical jungles. Different plant communities occupied different environments. Towering conifers rose above the landscape. Seed ferns spread across floodplains. Glossopteris forests still survived in parts of the southern hemisphere, although their dominance was slowly fading. Closer to rivers and wetlands, dense vegetation created habitats for countless smaller animals. The air itself was different from the one we breathe today. Oxygen levels had gradually declined compared with earlier periods in Earth's history. Most animals had already adapted to these conditions, but life often existed closer to its physiological limits than many modern ecosystems. The oceans also appeared calm. Warm currents circulated through Panthalassa, while smaller inland seas connected different coastal regions. Coral-like reefs supported astonishing biodiversity. Schools of fish moved through clear water above forests of crinoids and fields of brachiopods. Ammonoids drifted through the open ocean, while countless microscopic organisms quietly formed the foundation of marine food webs. Everything remained connected. Plants captured sunlight, herbivores consumed plants, predators hunted herbivores. When organisms died, fungi and microorganisms returned nutrients to the soil and water, allowing new life to grow. Millions of species depended on countless invisible relationships. The disappearance of only one important group could disturb an entire ecosystem. The disappearance of many groups at once could bring everything crashing down for millions of years. Earth maintained this delicate balance. There had been climate fluctuations before. Sea levels had risen and fallen. Volcanoes had erupted. Mountain ranges had formed. Life had survived every challenge. Each time, evolution slowly rebuilt what had been lost. Nothing in the fossil record suggested that the coming disaster would be unlike anything before it. This would not be a regional catastrophe. It would not affect only one continent. It would not last for only a few years. Instead, the processes that were beginning deep beneath Siberia would continue for an immense span of time. Each eruption would release more gases. Each pulse would place additional stress on ecosystems already struggling to adapt. The planet would not collapse in a single day. It would deteriorate gradually, year after year, century after century, generation after generation. Animals would continue reproducing without realizing that their descendants faced an increasingly hostile world. Forests would still appear healthy in many places, while invisible chemical changes slowly unfolded in the atmosphere. The oceans would still shimmer beneath the sun, while deep waters quietly began losing oxygen. To any single creature, the changes would seem almost impossible to notice, but across thousands of years, they would accumulate. The Earth had entered the first stage of a crisis from which there would be no easy recovery. Soon, the ground beneath Siberia would finally break open, and the largest volcanic event known from Earth's history would begin. The first eruptions may not have seemed extraordinary. Volcanoes had always been part of Earth's history. They built islands, raised mountains, and occasionally transformed local landscapes. Life had survived countless eruptions before. There was little reason to believe that this time would be different. But beneath what is now Siberia, something almost unimaginable was unfolding. Instead of a single volcano, or even a chain of volcanoes, an enormous region of the Earth's crust began releasing unimaginable quantities of magma. Cracks stretched across the land. Molten rock poured onto the surface again and again. Each new eruption spread fresh layers of lava over the previous ones. Some individual lava flows traveled for hundreds of kilometers before finally cooling into solid rock. The eruptions did not end after weeks. They did not end after years. They continued over hundreds of thousands of years, with repeated pulses of volcanic activity reshaping the landscape again and again. Today, geologists know this event as the formation of the Siberian Traps. The word traps comes from the Swedish word for stairs, describing the immense step-like layers of hardened basalt that still cover vast parts of Siberia. Together, these volcanic rocks once extended across an area measuring several million square kilometers. The visible lava alone was extraordinary, but the greatest danger remained hidden beneath the surface. As magma forced its way upward, it passed through enormous deposits of coal, limestone, and other carbon-rich rocks. The intense heat baked these underground layers like an enormous geological furnace. Instead of remaining locked safely beneath the ground, vast quantities of carbon dioxide, methane, sulfur compounds, and other gases escaped into the atmosphere. Each volcanic pulse released another wave, then another, and another. The atmosphere slowly began to change. At first, no animal could possibly recognize what was happening. There was no single day when the air suddenly became deadly. Instead, greenhouse gases accumulated little by little, year after year, century after century. The balance that had supported life for millions of years slowly shifted. Average temperatures began to rise. Rainfall patterns changed. Some regions became even drier than before. Others experienced increasingly unstable weather. Plants that had flourished for countless generations suddenly found themselves struggling to survive under new conditions. Forests weakened as vegetation declined. Soils became more vulnerable to erosion. Heavy seasonal rains carried enormous amounts of sediment into rivers and eventually into the oceans. The atmosphere continued warming. The oceans absorbed much of this additional heat. Warm water holds less dissolved oxygen than cold water. At first, the effects were subtle. Most marine animals continued living as they always had. But deep below the surface, the chemistry of entire oceans was beginning to change. The volcanic eruptions showed little sign of stopping. Every new pulse pushed the Earth farther away from the stable world that life had always known. The planet was entering unfamiliar territory, and the consequences would soon spread far beyond Siberia. The greatest extinction in Earth's history had truly begun. As the centuries passed, the changes became impossible for the planet to absorb. The atmosphere continued filling with greenhouse gases released by the immense volcanic activity. Carbon dioxide accumulated faster than natural processes could remove it. Global temperatures kept rising. Entire climate systems began to shift. The warming did not happen overnight. It unfolded slowly enough that individual generations of animals adapted as best they could. But over thousands of years, the difference became enormous. Many regions that had once supported healthy forests grew increasingly hot and dry. Long periods of drought became more common. Wildfires spread across landscapes that had rarely burned before. Even where forests survived, they became weaker and less resilient. Plants experienced growing stress from higher temperatures and changing rainfall. When forests declined, countless other species lost both food and shelter. The effects reached far beyond the land. The oceans absorbed much of the excess carbon dioxide from the atmosphere. As more carbon dioxide dissolved into seawater, the chemistry of the oceans slowly changed. The water became more acidic. For organisms that built shells or skeletons from calcium carbonate, this created an entirely new challenge. Many struggled to grow. Others reproduced less successfully. Some populations began disappearing altogether. Meanwhile, warmer surface waters mixed less effectively with the colder depths below. Fresh oxygen reached deep water more slowly. Over time, vast regions of the oceans became depleted of oxygen. Entire communities living near the seafloor found themselves trapped in water that could no longer support complex life. Some microorganisms flourished under these conditions. Certain bacteria produced hydrogen sulfide, a poisonous gas deadly to most plants and animals. Evidence preserved in ancient rocks suggests that oxygen-poor waters expanded across large areas of the world's oceans during this crisis. Food webs that had remained stable for millions of years slowly unraveled. Species disappeared one after another. The loss of a single group affected predators. The disappearance of predators affected prey. Each extinction triggered another. The collapse spread through ecosystems like falling dominoes. On land, rivers carried increasing amounts of dead plant material and eroded soil toward the sea. Coastal waters changed, habitats shrank. Many species found themselves surrounded by environments they had never evolved to survive. The crisis was no longer limited to one region. It had become planetary. No continent escaped the changing climate. No ocean remained untouched. Life had faced difficult times before, but never had so many destructive forces acted together for so long. The Earth itself had become hostile to the organisms that called it home, and the worst was still yet to come. The oceans had always been Earth's greatest refuge. They covered most of the planet, regulated its climate, and sheltered an extraordinary diversity of life for hundreds of millions of years. Marine ecosystems had survived, changing coastlines, shifting continents, and countless volcanic eruptions. This time would be different. As the planet continued warming, the oceans changed from the surface to the deepest abyss. Warm water naturally holds less dissolved oxygen than cold water. At the same time, the increasing difference between warm surface waters and cooler deep waters reduced the mixing that normally carried oxygen into the depths. Slowly, almost silently, vast regions of the ocean began to suffocate. Animals living on the seafloor were among the first to suffer. Many could not simply swim away. Brachiopods that had covered enormous stretches of the seabed began disappearing. Crinoids that had filtered food from gentle currents found themselves living in increasingly hostile water. Ancient reef communities, which had taken millions of years to develop, started to collapse. Coral-like reef builders died in enormous numbers. As reefs disappeared, thousands of other species lost the habitats they depended upon. The collapse spread outward through the ecosystem. Predators lost prey. Scavengers found fewer remains. Filter feeders encountered changing currents and declining food supplies. Every level of the food web became unstable. Far below the surface, oxygen-poor waters expanded across entire basins. In some regions, microorganisms that thrive without oxygen multiplied rapidly. Their activity produced hydrogen sulfide, a toxic gas capable of killing many forms of marine life. Evidence preserved in ancient sediments suggests that these poisonous conditions became widespread during parts of the extinction. The water itself was becoming dangerous. Many animals faced several deadly challenges at once. Higher temperatures increased metabolic demands. Lower oxygen made breathing more difficult. More acidic seawater weakened the ability of shell-forming organisms to grow and reproduce. Food became increasingly scarce. Very few species were capable of adapting to all of these pressures simultaneously. The ammonoids, once abundant throughout the oceans, experienced catastrophic losses. Many ancient fish lineages disappeared. Entire families of marine organisms that had survived previous extinction events finally reached the end of their evolutionary history. Among the most tragic losses were the trilobites. For more than 270 million years, they had inhabited Earth's oceans. They had survived multiple global crises. Generation after generation had adapted, while continents drifted and climates changed. Now, at the end of the Permian, the final trilobites vanished forever. No descendants remained. An entire branch of life that had witnessed nearly the whole Paleozoic era simply disappeared from the planet. By the time the crisis reached its peak, marine ecosystems had been transformed beyond recognition. Scientists estimate that around 80 to 90% of marine species disappeared during the end-Permian extinction, making it the greatest loss of ocean life known in Earth's history. The seas that had once overflowed with life became strangely quiet. Many habitats stood nearly empty. The greatest extinction on land was still unfolding. But beneath the waves, the old world had already fallen. While the oceans were collapsing, the disaster continued spreading across the land. The forests that had once covered vast regions of Pangaea no longer resembled the thriving ecosystems of earlier ages. Long periods of drought weakened enormous areas of vegetation. Higher temperatures placed constant stress on plants that had evolved under a very different climate. Wildfires became increasingly common. Evidence preserved in ancient rocks shows repeated episodes of burning across large parts of the supercontinent. Entire forests disappeared without dense vegetation to hold the soil in place. Heavy seasonal rains stripped enormous quantities of earth from the landscape. River systems changed. Floodplains became unstable. Nutrients that had once supported rich ecosystems were washed away. As plants declined, herbivores faced a growing shortage of food. Some species migrated in search of better conditions. Others found no refuge at all. Population after population began shrinking. Predators soon followed. Even the strongest hunters depended entirely on healthy populations of prey. When herbivores became scarce, predators also began to disappear. Food chains that had remained stable for millions of years slowly unraveled. Many species were confronted by several crises at once. Temperatures continued rising. Fresh water became less reliable. Vegetation became increasingly sparse. Reproduction slowed. Young animals were less likely to survive to adulthood. Each generation became smaller than the one before. The extinction did not happen everywhere at exactly the same moment. Different regions experienced the crisis in different ways. Some ecosystems declined gradually. Others collapsed surprisingly quickly. But over time, the outcome became the same. The diversity of life continued falling. Many familiar groups vanished forever. Large herbivores that had once dominated the landscape disappeared. Powerful predators that had ruled for millions of years came to the end of their evolutionary history. Entire branches of the tree of life were cut away. The world grew quieter. Forests that had once echoed with countless forms of life became strangely empty. Across enormous stretches of land, animals that had been common for millions of years could no longer be found, yet a handful of survivors endured. Among them was Lystrosaurus. It was not the largest animal. It was not the fastest. It was not the most specialized. Ironically, those very qualities may have helped it survive. Its simple diet, compact body, and ability to tolerate difficult conditions appear to have given it an advantage while more specialized animals disappeared. After the extinction reached its peak, Lystrosaurus became one of the most widespread large land animals on Earth. Its fossils have been discovered across regions that are now Africa, India, Antarctica, and other continents that were once joined within Pangaea. The dominance of this single survivor illustrates just how completely the previous ecosystems had collapsed. The familiar world of the Permian was gone. Only scattered remnants of its once extraordinary diversity remained. Life had not disappeared entirely, but it had been reduced to a shadow of what it had once been. The greatest mass extinction in Earth's history was nearing its end. The planet that emerged afterward would be almost unrecognizable. When the extinction finally reached its end, the Earth was still alive, but it no longer resembled the vibrant world that had existed before the crisis. Entire ecosystems had vanished. Ancient forests had been reduced to scattered patches struggling to recover. Coral-like reef systems that had flourished for millions of years were gone. Many rivers flowed through landscapes supporting only a fraction of their former diversity. The silence of this new world was unlike anything the planet had experienced before. Scientists estimate that the overwhelming majority of marine species disappeared, while on land many groups of vertebrates, insects, and plants suffered catastrophic losses. The extinction was so severe that it permanently reshaped the history of life. Some evolutionary lineages ended forever. Others survived only through a handful of species. Entire branches of Earth's family tree simply stopped growing. The survivors inherited an almost empty planet. Competition had nearly disappeared. Predators that once dominated entire regions were gone. Many familiar herbivores had vanished. Countless ecological roles no longer had anyone to fill them. Yet surviving did not mean thriving. The environment remained unstable. Volcanic activity continued. Temperatures stayed unusually high. The oceans still contained vast oxygen-poor regions. Many landscapes remained dry and difficult to inhabit. Recovery would not happen within a few generations. It would not happen within a few centuries. Even after the extinction itself had ended, ecosystems required millions of years to rebuild their complexity. The first communities were remarkably simple. A small number of hardy species spread across enormous areas. In many places, Lystrosaurus became overwhelmingly dominant. Instead of rich ecosystems containing hundreds of interacting species, entire landscapes could be occupied by only a handful of common animals. Nature had not returned to balance. It was starting almost from the beginning. The oceans told the same story. Many seafloor habitats remained nearly empty. Ancient reef systems did not immediately return. Marine food webs were greatly simplified. Groups that had dominated the Paleozoic seas for hundreds of millions of years were gone forever. The Earth had crossed a boundary unlike any before it. This was no ordinary extinction. It marked the end of one great chapter of life's history. Everything that followed would develop in the shadow of this catastrophe. The Paleozoic world had ended. A new era was slowly beginning. But before entirely new ecosystems could emerge, evolution first had to rebuild a planet that had come astonishingly close to biological collapse. Recovery came slowly. Far more slowly than anyone standing on that ancient Earth could ever have imagined. The extinction itself may have unfolded over a geologically short span of time, but rebuilding the planet's ecosystems required millions of years. The survivors entered a world that was still unstable. Temperatures remained high. The atmosphere and oceans had not yet returned to their former balance. Many environments continued changing long after the worst of the extinction had passed. The first ecosystems were simple. Only a limited number of species occupied landscapes that had once supported extraordinary biodiversity. Slowly, generation after generation, evolution began filling the empty spaces once again. Plants spread across damaged ground. New forests gradually appeared. Fresh food webs developed. Predators evolved to hunt the growing populations of herbivores. The oceans also recovered, though even more slowly. Ancient reef systems did not immediately return. New groups gradually replaced many of the organisms that had disappeared forever. Life was not rebuilding the old world. It was creating an entirely new one. The extinction had permanently changed the direction of evolution. Many of the dominant groups of the Paleozoic era never returned. Instead, other lineages began expanding into ecological roles that had once been occupied by very different animals. During the millions of years that followed, one particular branch of reptiles slowly diversified. At first, they were neither especially large nor especially dominant. They lived alongside many other surviving groups that were also attempting to establish themselves in the recovering world. But the empty ecosystems offered opportunities that had never existed before. As evolution continued, these reptiles gradually spread into new environments. Some became swift predators, others evolved into enormous herbivores. Much later, their descendants would come to dominate the planet for more than 160 million years. They were the dinosaurs. In a very real sense, the age of the dinosaurs became possible because of the greatest extinction Earth had ever experienced. Without the collapse at the end of the Permian, the history of life would almost certainly have followed a completely different path. The Great Dying was not simply the end of one world. It was the beginning of another. Today, the rocks of Siberia still preserve the immense lava flows that helped transform the planet. Ancient sediments still record the disappearance of countless species. Fossils still reveal both the incredible diversity that once existed and the small number of survivors that carried life forward. They remind us that Earth's history has never been a straight line. Life has endured unimaginable disasters. Again and again, it has adapted, recovered, and evolved into forms that no previous age could have predicted. The world we know today exists because countless others came before it. Some flourished for millions of years, some vanished forever, and among all the turning points in the history of our planet, none was greater than the event we now call the Great Dying.